here's where in this short course on meteorology I spend less time than I would if it was a 16-week course. But do you remember a few slides ago I had a parcel of air down here, and we were talking about mixing ratio and absolute humidity, and then I had a parcel of air here, so basically it was rising in elevation and it was expanding, okay? And that actually, that expansion happens as a parcel of air rises in our atmosphere. And one of the things we haven't talked yet about, but we're going to get to it, is basically the air is thinner up here. It's thinner. And you usually know that as you climb a mountain, and the air is thicker down here. And literally there's more particles here and less particles of air up here. And actually, because of that, a chunk of air rising will actually have a less pressure up here, and a chunk of air will expand. So I don't know if you buy that, but it is true. And as it expands, actually it is doing work. So it's doing work. I'll put a W for work. And as it's doing work, it has to be funded by something. So my whole point is this whole rising, expanding, and doing work makes this parcel of air cooler up here. That's it. It's cooler up there. Actually, we call that adiabatic cooling. Adiabatic. Because it's just that no energy has left the parcel or come into the parcel. It's just the parcel itself. So that's adiabatic cooling. So, if you're fine with that, then as we cool, then we get to pick out a different saturation amount on that table that we looked at before. So as we cool, basically, the chunk of air can hold less water vapor. So condensation can occur as a chunk of air rises. Bottom line, okay? So there are actually ways that chunks of air will rise. And one of the ways is if you have a parcel of air that is slammed up against a mountain, then it has to go up. Okay, I have an example down here. We call that actually that mechanism of lifting a chunk of air, or graphic lifting. And again, if a chunk of air can lift, it will cool, and if it's got water vapor, it can go ahead and condense. So here we have, I don't know if you can see this figure, but up at the top of this mountain where orographic lifting has occurred, we have condensation happening. Remember I said anytime you can see a milky white cloud, I'm hoping that you think liquid. Okay, so condensation has occurred. Another way to get a chunk of air moving, and we're going to talk more about this coming up, is if you actually have what we call a weather front. Okay, a weather front is just basically you have two chunks of air, two air masses that are meeting, and where they intersect is called the weather front. And that's another lifting mechanism, frontal lifting. And then another one happens actually routinely on a nice sunny day. So what can happen is, if you've ever worn a dark shirt, okay, you know that, and it's sunny outside, the dark shirt will absorb more heat. And so also, if we kind of have these uneven kind of, this is one way to get kind of a chunk of air that is got more heat than the rest. If we have uneven coloring, then we have different amounts of the light that's going to be soaked up by the earth. So anyway, here we have kind of a dark pattern, looks kind of like a fields, doesn't it? Where this is hot, okay, because of its different amount of energy that it's soaked up relative to its surroundings, and it creates this warm bubble of air. And if you've ever heard, like in your house, if you go upstairs, it's the warmest temperatures, that's because warm air rises. Warm air, and that's basically, we call this actually convective lifting. Your warm air will rise. All right, and then the last one is what we call convergence lifting. And an example here is where air is being swept along the ocean, nice and smooth, okay, and here it hits land, and here it's there's a little more friction here, okay, and actually that builds up kind of a place for it to kind of squish together and rise up. That's called convergence lifting. So we'll take, let me see, I'll kind of think I'll do this guy down here. if I take this chunk of air, okay, that got warmer and it's going to start to rise, okay, that chunk of air will be here expanded and then here expanded, okay, and then it's cooling all the time, all the while. Now, the elevation or the level that it needs to rise to and expand in order for condensation to begin is called the lifting condensation level. Lifting condensation level is an elevation, like I said, at which you kind of see the bottom of the cloud. That's the LCL. Okay, LCL.